Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
So graphing trig functions, I know we are comfortable with using angles, but angles get to really big numbers really quickly. In order to make a full revolution on a circle, our angles have to go all the way to 360 degrees. But when we're looking at the circumference of a circle, the circumference is just 2 pi. So we really want to make sure that when we're graphing on a unit circle or whatever, is we're trying to take all these values from the circle, right? And we'll notice that, let's just look at the x value or the y value. So see how the y is 0, then it grows to 1/2, then it grows to 1.7-ish, then it grows a little bit more. I guess that's 0.707 actually, not 1.7. We grow to 0.86, then we get to 1. Now we start shrinking again, 0.86. The y's are coming back down, right? And then they're going to go negative. Then they're going to come back to 0. Then we're going to repeat the process. And so the highest y value we get is 1, and the lowest y value we get is -1. So that's why a sine wave is going to stay between 1 and -1, okay, no matter our angle, and it repeats. But we don't want to have to draw 360 degrees. So if you're graphing on a graphing calculator or Desmos, make sure your calculator says you're in radians, okay? But I have some basic 5 steps that we're going to go over really quick to make sure that you can graph these without a calculator as well. Because ACT, things like that, who knows why, you might not get a graphing calculator. So we're going to have steps. Step 1. Okay, you need to rewrite it as A multiplied by, you're going to have some trig word, B x minus C plus D. Your A, B, C, and D value are all going to mean something. And you'll notice that right here, this is x minus c. Not 2x, not anything else, just x. You need to get it in this format before these other steps will work. Okay. Step 2. You're going to find the period length. Okay, now the period length is the time that it amounts to repeat. So if you're dealing with like periodicals, like the Sunday Times, the Sunday paper comes out once a week. Whereas, the Kansas City Star comes out once a day. Maybe a certain clothing magazine comes out 4 times a year. Okay, so the period in between would be 3 months. Every 3 months you get a new magazine. So the period length just means how long until it happens again. Okay, so if you're doing, so you have options on this one. I'll switch colors for this. Sine or cosine, and therefore cosecant or secant, you will be doing 2 pi divided by the b value. If it's tangent, or therefore cotangent, you'll be doing 1 pi divided by the b value. Okay, so period equals. That is a really bad b. Where am I getting that b value from? Right here. And that's because the bigger this value is, the faster it's going to repeat. And so the less time it takes to repeat. Okay. Step 3. Find your phase shift. Okay, your phase shift will be C. because if you've ever noticed, this is kind of like the horizontal shift. The C value is how much you're going to shift left or right. And just like back in Algebra 2, that number there is going to be your phase shift, and it's always the opposite of what's in parentheses. Okay? Step 4. Find your 5 key values. And we need these key values so that we can know what our scale factor is, so that we can actually understand what is on the calculator. Okay, so our 5 key values. This is where it's going to be really key to come in here. Okay. C, your phase shift is going to go right there. C plus P is going to be there. And then you're just going to do middle, middle, middle to get your other numbers. So even take P, divide it by 4, and that's what you go up each time. Okay? So plus P over 4, plus P over 4, plus P over 4, plus P over 4. That's all you're going to do. Okay? Now, it's important to understand like how to use common denominators and things like that so we can make sure our numbers make sense. We can't just randomly start in the middle of nowhere. Okay? Step 5. Graph with a graphing calculator. Keeping in mind that you need to be in radians mode. Okay. Your X scale should demonstrate or should be based off your 5 key values. Okay. And make sure you show at least 2 periods. Okay. Now, just an extra note for sine and cosine. D will be your center line, and A will be your amplitude. And I'll eventually explain why, it only works there. Now, if you were to shift something 2 pi, well, that's to go and shift it a full circle. So you're really not shifting at all if you shift it 2 pi. Okay? So let's just look at basic sine and cosine. Okay, they're written in our A value is 1, our B value is 1. There's no plus or minus, or C value is 0, and our D value is 0 for both of these. Okay, so they're going to have, so remember on our 5 key values, okay, 2 pi divided by our B value is 2 pi. So that's what our period length is. C is 0, so 0 plus 2 pi is 2 pi. And then if we take that and we divide it by 4, we get pi over 2. So plus pi over plus pi over 2, plus pi over 2. Oh, it makes sense. It's 0, pi over 2, pi, 3 pi over 2, 2 pi. Ah, now I'm repeating. Okay. So I'm going to graph 1, 2, 3, 4. There's 2 pi, and I'm going to go backwards. 1, 2, 3, 4, negative 2 pi. And I numbered by pi over 2, so I know my scale factor. So I'm going to come in here, y equals. Turn off that light. There we go. I'm in radians, so that's good. I want to graph sine of t. I have an x. My window, I'm going to go from negative 2 pi to 2 pi. And my scale, I numbered on my paper by pi over 2. This is why I never use zoom or standard, because I want to control what my scale factor is. So it's really big here. Okay. Now, if you remember, the largest my circle ever got was a radius of 1. So my x values and my y values never went further than 1 away. So I'm just going to go negative 3 to 3 right now. Okay. Ah, and if you remember, sine was about your y value. So our y value, again, started at 0. And by the time we got to pi over 2, our y value was 1. That's why it starts at 0. When we get to pi over 2, our y value is 1. So we can actually see this. We're at that peak, right? So 0, 0. Pi over 2 is at 1. Pi is at 0. 3 pi over 2, that was our next important number. That's at negative 1. And 2 pi. It's not letting me because that was right on the edge of my window. But 2 pi is right here on the edge. Is at 0. And then it repeats. So if you've ever heard something called a sine wave before, that's what's going on, is a sine wave. And it just keeps going and going, right? All right, so what will happen different with cosine? Well, we still have the same key values because it's the same phase shift, things like that, right? So 1, 2, 3, 4, there's our 2 pi. 1, 2, 3, 4, negative 2 pi. But remember, cosine was about my x's. So how is that going to differ? Oh, it's still waving, but, oh, that's really blurry. Come on. You can do it, computer. Now, at 0, we see we're at 1. At pi over 2, we're at 0. At pi, we're at negative 1. 3 pi over 2, 2 pi. Let's look at those on the same thing. I got a little wonky there. Okay, so cosine will be in blue, sine will be in red. Oh, they're basically the same graph. I just would have to shift red left to be on top of blue, or shift blue right to be on top of red. And that's the case, right? So if you know your 5 key values, it'll either be the center line, the maximum, or the minimum. So knowing those 5 key numbers will either be the center line. See how they oscillate around 0? It'll be the maximum or the minimum. All right, so let's test this out. F of t equals 3 sine of t minus pi minus 4. Okay. Well, A equals 3, B equals 1, C equals pi, and D equals negative 4. Okay, so I found A, B, C, and D. So I need to find my period. So P, because this is sine, is going to be 2 pi divided by my B value, which is 2 pi. My phase shift is C. I actually already did my step 3. So step 4 is I'm going to put things together. I need my 5 key values. 1, 2, 3, 4, 5. Pi. Okay. So now I need to take pi plus 2 pi. That'll be 3 pi. Now some people don't like to do another thing. Well, it's halfway between 1 pi and 3 pi. 2 pi. What's halfway between 1 pi and 2 pi? 1.5 pi's. What's between 2 and 3? 2.5. And 5 divided by 2 is 2.5. Okay, there are our 5 key values. Okay. One, 2, 4, 5. Okay, so I'm going to back up the truck. Okay, so 1 to 3 is the same distance as negative pi to pi. So I just added some extra stuff on there. Again, could I have gone forward instead of going backwards? Yes, I just like to have 0 involved if I can. Okay, 3 sine of t minus pi minus 4. And I started at negative pi, and I went to 3 pi. And my spacing was pi over 2, because I numbered by half a pi. Graph. I'm not seeing very much. I saw the whole thing before. Why am I not seeing it now? Let's go back out to a normal y. Leave my x's like they are. Ah, so it's giving that sine wave. Well, I haven't talked about the a value and the d value. A value is positive 3. That's not really helping me out. Let me graph this line right here, negative 4. Ah, remember I said D would be your center line? Yeah. So what's going to happen here is we're going to come down to 1, 2, 3, 4. And that's going to be our center line. Okay? Now, at 0, see how the sign is, well, sorry, we need to go to pi, because that was where we started. At pi, it's in the center line. Just like here, originally we started at 0, was in the center. But we're shifting this right pi. So at pi, we're on the center line. What about at our next number? 3 pi over 2. We're at negative 1. What about at 2 pi? Negative 4, back that center line. And 2.5 pi. Now I'm at negative 7. So that's negative 4, negative 5, negative 6, negative 7. And 3 pi is going to be back on that center line. Okay. So we got the full up and a full down. So I got one full wave. So I need to get my second one on there. So I'm just going to repeat. Unfortunately, my numbering got a little wild and crazy. And I squished it in there because I didn't make it perfectly. This is where grid paper comes in nice sometimes, right? Whoops. Didn't go up high enough, did I? Okay, so what you should be noticing is that, see how the peak is 3 above the red line? And the valley is 3 below. So we went middle, 3 up, middle, 3 low, middle, 3 up, middle, 3 low. You can start here. Middle, 3 up, middle, 3 low, middle, 3 up, middle, 3 low. Why? Well, this was our center line. This was our amplitude. Okay? So the amplitude refers to how much you go up or down from your center line. Okay, let's say you have this. Well, they have done this to throw you off. They're trying to mess you up. Okay? Now, I am going to tell you that your A value, while it's -2, your amplitude is just 2. 2 up, 2 down. Okay? Our B value is 1/2. You cannot see your C value right now, so don't even mess with that. And D is 0. So it's going to oscillate around the x-axis. It's not going to be shifted up or down. Okay. And we still haven't calculated P. But we need to rewrite it. That's really what step 1 is about. Okay. So we have to have it written in this form. So 1/2 times what is pi over 4? If you said pi over 2, you would be correct. Okay. So our C value is left pi over 2. Left pi over 2. That's our first key value. Okay. Period equals 2 pi divided by 1/2, which is 2 pi times 2, which is 4 pi. Okay. So I could come in here and go negative pi over 2 plus 4 pi. But do you know what that means? No. So I could say negative 1/2 plus 4, and I get 7/2. Now if I times that by pi, is it the same thing? Yes. So I'm going to end at 7 pi over 2. So if you're struggling with figuring out these calculations, if you don't type pi in the calculator, you can use your calculator to help you out. Now, whatever this is, if you divide it by 4, it will tell you what to make your jumps by. And we divide it by 4, we just get pi. So negative 1/2 a pi plus a whole pi, we're at 1/2 a pi. Then at 3/2 pi, then at 5/2 pi. You can see it now. See how the numerator is odd numbers? -1, 1, 3, 5, 7. Yeah. And the nice thing is they have a common denominator all the way through. So when I go to make my graph, -1/2, 1/2. Okay, there would be 1, there's 1 1/2, there's 2, there's 2.5, there's 3, there's 3.5. Okay, now here's the thing is, those are just my first 5 key values, right? I'm only going to get one phase. I've got to keep going. I need to add another 4. What is 7/2 plus 4? I need to go all the way out to 15/2 to get 2 full periods in here. So there's 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5. So I have more marks on here than I actually need. But the key ones are like every other mark, right? And I had to do that because I had to keep my scale factor going. I can't number by pi over 2 in one spot and then number by whole pi's in another spot. Okay. So in my window, I went from, we'll just go negative pi. 15 pi, we'll go 16 pi over 2 or 8 pi. And we numbered by pi over 2's still. That's not normal, but oh well. And our equation is -2 cosine of 0.5x plus pi over 4. Okay, and our first key value was negative pi over 2. That was our C value. It was indeed down 2. So negative pi over 2 was right here. Our next key value was pi over 2. That was at 0. 3 pi over 2 was at 2. 5 pi over 2. Oh, back to 0. Big surprise, right? 7 pi over 2. Oh, back to -2. Do we need to keep calculating or do we have this? Hopefully we have it. Because if we're here, we're back to 0, then up to 2, back to 0, down 2. And we get our, now why is it a cosine wave instead of a sine wave? Well, because it was a cosine graph. Can a cosine graph be made into an equivalent sine graph? Absolutely. Okay, now, normally cosine graphs, if you look back at the original cosine graph, it started up high and did this. Because it was negative, it started down low. Because it just kind of reflipped it. So just like in, Algebra 2, when your a value, if it was negative, would cause a reciprocal function to happen. The same thing is happening. It's really hard to see when we could start in any spot and write an equivalent function that it would flip and things like that. Okay, let's go ahead and try one more. And if you can get your 5 key values written down, you can graph these things, all right? All right. By the way, if you notice, it stretched our period out. It took 4 pi's before it repeated because it was repeating half as fast. So just so you know, the bigger that is, the more zoom, 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 zoom you get. So the higher the number, the more you get that. The lower your number, the more you get this. Okay? So just something to think about as you do that. When we're graphing them with different scales to try to make it easier on ourselves, sometimes we don't always see that. So I just kind of wanted to point it out. F of x is going to equal 3/4 sine of 2x plus 2 pi over 3. Oh, I did it again, where you have to rewrite that darn thing. So 3/4 sine. 2 times what is 2/3? Well, that would be 1/3. Okay. And so A is 3/4. So that means we're going to go up 3/4, down 3/4, up 3/4, down 3/4. That's all that's going to mean. So it's really not going up and down much. Our B value is 2. So it's going to repeat twice as fast. So our period is going to equal 2 pi divided by 2. Ooh, it's going to repeat every pi. Our C value is negative pi over 3, so it's going to start to the left. And our D value is nada. We don't have anything at the end. Check. Okay. So 1, 2, 3, 4, 5. We are going to start at negative pi over 3. And if we take our pi, our p, and divide it by 4, we get pi over 4. So we're going to plus pi over 4 each time because we know negative pi over 3, negative 1/3 plus 1 whole is going to be 2/3 of a pi. Okay, so we're at negative 1/3 right now. We need to add 1/4, not 1/7. Ooh, so that'd be negative pi over 12. Pi over 6. 5 pi over 12. And hopefully that's that 2 pi over 3. It is. Okay, so what should we number by? What should we number by? Well, the common denominator is 12, so I'm going to number by 12ths. One, 2, 3, 4 twelfths. That's pi over 3. 1, 2, 3, 4 twelfths. That's 2 pi over 3. 1, 2, 3, 4 twelfths. There's finally pi. 1, 2, 3, 4. That would be 5 pi over 3, right? No, 4 pi over 3. 1 1/3. 1, 2, 3, 4. There's 2. There's our 5. Okay, so 1, 2, 3, 4. There's negative pi over 3. Okay, so my scale is 1/12. So here's negative 1/12. Here's negative pi over 3. Pi over 6 is 2/12. 5 twelfths would be right here. And then we have, so now that I have those on there, we see it's hash mark, 1, 2, 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 hash mark. There we go. Now we're getting that pattern, right? So now we definitely have our scale down. Now, since our amplitude is only going to be 3/4, I'm going to draw this so that 1 is up here and negative 1 is down here. That way I can see where my 3/4 is. All right. So y equals 3/4 sine of 2x plus 2 pi over 3. I write it the exact same way as the original. That way I know to make sure I don't have any mistakes. I'm going to hit graph. Okay. Well, this got very repetitive very quickly. Okay. So let's just calculate my first important number. Negative pi over 3. It's in the center, it's at 0. My next important number, negative pi over 12. It's at 3/4. It's at that top like I thought it would be. Okay, so pi over 6 should be back in the middle, right? Yep, there it is. That means my 5 pi over 12 should be at the bottom. Yep, negative 3/4. And so my 2 pi over 3 should be back in the middle. There it is, back in the middle. We've got it. So middle, top, middle, bottom, middle, and I could keep going, right? And there we go, there's our sine wave. Okay, now I do want to kind of back out here and just focus on something really quick. So comparing sine of x to, we'll do sine of 3x. What you should see is you should see 3 times as many of the red as you do the blue because it's tripled its speed. So you get a lot more cycles in the same amount of space. So that's kind of what that value does in there. And you might not always be able to see it because we're adjusting our scale so much to be accurate to this. Now, I'm going to make another video so that I don't have to make one big long video where I focus on the other trig graphs. But if you can graph sine and cosine, you are going to be able to do all of these, okay? So the reciprocal functions are really, really a nice little just quick fix if you can do sine and cosine.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.